Hello everyone, my name is Etienne Ikamen.
And I'm Chris Orr.
I'm Nathan Doe.
I'm Nolan Muller, and we're chemical engineering students at the University of Michigan. Today we'd like to teach you about heat transfer through fluids.
The transfer of heat through fluids is used every day. For example, boiling a pot of pasta uses convection to cook the pasta. Convection is a mode of heat transfer that's characterized by the movement of fluids.
Another example of convection is heating your home. The hot air in the vents is responsible for raising the temperature of the house.
Finally, cooking with hot oil, like in a deep fry or in a saute pan, uses the same principles to cook your veggies or your french fries. These principles will be demonstrated in our experiment.
The purpose of our demonstration is to evaluate the effectiveness of heat transfer through common household fluids. We will be testing air, water, salt water, and vegetable oil.
Here we have 4 small beakers filled with water and 4 large beakers filled with the respective mediums. We will be placing these small beakers in the large beakers and be applying the same heat source to all 4.
As you can see, we've placed the 4 beakers on the same hot plate. Before we turn it on, we'll measure the temperatures of the 4 small beakers.
The 2 modes of heat transfer demonstrated in this experiment are conduction and convection. Conduction is characterized by the contact of 2 surfaces, usually both solids. Convection, on the other hand, is caused by fluid motion. After the hot plate is turned on, heat is transferred by conduction through the large beaker. From there, heat is transferred through the fluid by both convection and conduction. Finally, this heat is transferred from the smaller beaker to the water it contains by conduction.
We'll measure the temperature difference after a set amount of time. This data, as well as the heat capacity of water, will allow us to calculate how much energy was transferred to the water. In addition, the medium that induced the largest temperature change is the one that is most effective in transferring heat.
After running our experiment, we found that vegetable oil was the best at transferring heat. This can be explained by its relatively low heat capacity, allowing it to get hotter faster. As the temperature of the vegetable oil increased, it began to boil, which only increased its ability to transfer heat.
The least effective medium in transferring heat is air. As you might have guessed, gases are less efficient in transferring heat. This is because the hot air leaves the beaker before it can transfer a significant amount of heat to the smaller beaker. Between these 2 extremes, the salt water was noticeably better at transferring heat than fresh water, because adding salt lowers the heat capacity.
These principles of heat transfer that we discussed today can be used to explain heating and cooling within enclosed pipes. This is important in the chemical engineering industry, as temperature has a significant effect of the quality of a finished product.
A lot of equipment used by chemical engineers also involves this heat transfer process. Heat exchangers and cooling towers both use one liquid to cool another. These processes can be very efficient while also remaining inexpensive.
We hope you learned a lot about chemical engineering and heat transfer and how it applies to your everyday life.
Go Blue!